Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Kong. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to share it with a friend, the on-demand recording will be made available shortly after we conclude our webinar today. If you have any questions for Victor, you can direct those to the Q&A tab on the right side of your screen. And if you just like to engage in dialogue with the rest of your audience members, you can use the chat tab, which is also on the right side of your screen. Throughout today's program, we will have a couple of polls, so be sure to keep an eye out for those. And we have several handouts and links available under the Handouts tab that will aid you with following along in today's presentation. And finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards. So on to our topic today. We'll be discussing Day Zero Service Mesh, and I'm joined today by Viktor Gamov, Principal Developer Advocate at Kong. Victor, it's my pleasure to turn the floor over to you. Thank you so much for being here with me today.
Hey, Cody, thank you so much for this introduction, and I'm super excited to be here to talking about one of my favorite subjects as search for developers. So the way how this talk is structured, I will on the very use a pattern and how this pattern of service mesh came about, and we will dive deeper into the different components that this pattern needs to implement, and after that there are more hands-on demo where you will understand how component play in order to build your next generation of application connectivity for your business. All right, so everything that I will be talking, it would be available, their code will be available, it will be available, so don't worry about this. There will be a bunch of the polls. You can ask the quick Q&A, and we probably will gonna run some right now because I want to understand something about my audience, and because of this, let me go in the slides. I will be running. This is relatively connected. So it used to be so easy. Everything was so simple, and our architectures were simple. 3 years. You have the business log in between. You do have some sort of like a presentation layer, and you have a layer that business logic communicates to store the data, store some of the persistence is there. So, but you think about this, it's actually never was that easy or simple. There always were some technologies that took care of some of the complexity, and over the iteration of the life cycle of the applications, of the systems, we come up with solutions based on technologies of our time. So at the time, maybe there was no, when we were building Java EE applications, today we call it legacy or monolithic applications. But maybe at that time we don't need to build a web scale business that needs to serve thousands and millions, tens of thousands, hundreds of thousands, and millions of users. So at some point, this architecture were good enough to serving certain problems, solving certain problems. However, we came into the world where we need to change this architecture. We need to refactor this thing, right? So we need to do refactoring to microservices if you want. My name is Viktor Gamov. I work as a developer advocate here at the Kong, in a cloud connectivity company, and we providing tools for developers to build their applications and solve all the connectivity needs. Also, we provide the solutions for API lifecycle management and some other things that developers can use. Today, I want to talk about one of the projects that we at Kong is actively contributing. It's open source project in CNCF sandbox right now. And I will show you some of the bits how we use this project and what kind of the product we built on top of this open source project. So You can always tweet me at GMUSSA. You can find me there. And if you have any questions, my DM is always open. Please follow Kong and Kuma Mesh. That's the name of this open source project, and the Kong, the company that I am working on. So we're sharing some of the developer materials there fairly regularly in the Twitter. All right. So, but microservices were not invented in 5 years ago or 10 years ago. There were it's just like approach how to build the systems. However, around 5 years ago, some of the tools emerged that allow to escalate the growth of the introduction of microservices to the systems. Tools like Docker and containers, tools like Kubernetes that allows to deploy those containerized applications. So over the time, developer productivity increases through the introduction of different tools, allow them to build a system and decouple system and break down the system. So, but let's get back to this diagram, right? And when we say in monolith, it's not like one whole thing, because somewhere here, like this part, maybe will be stored in a different place in a different system. So your database administrators will be continue doing their stuff separately from people who will be writing and deploying your some of the business logic. And in the many use cases, we also can offload this kind of like dynamic web pages somewhere where we can apply some of the caching, some of the proxying, all the stuff. So even though we're talking about this as a monolith, it's not like monolith per se. There still will be networking. There still will be communication between the systems, and somewhere here we can have problems when the application will need to try to connect to this database, or the proxy server and some of the dynamic web pages JavaScript will try to communicate with API here, and also network can break here. So it's not per se a like monolith. It's not one big thing that runs in one computer. And usually, if I will simplify, and I will bear with me because this you will see this diagram. I'll try to build up on this diagram and explaining how this idea of service meshing came about. So the monolithic application needs something to communicate with the database. Usually we use this transport layer protocol, L4 protocols like TCP, because we can have a reliable connection between the systems, so we can have a streaming between this and the submit requests, getting response from database. And it stuff goes over the network. When we were thinking about web scale and running multiple systems, multiple services, those services not necessarily needs to be running on different machines in this particular case. Each monolithic application can include the service that will communicate it to this database somehow. So we already have in the monolithic world, in the world where we have a bunch of the components, bunch of services communicating with each other, maybe like you call in the interface from one piece of the code to another piece of code. And in this case, we're moving from the concept of the running your computation. In this particular case, we have this computation like some business logic that one object will call another object by calling some of the method of this interface. And with the microservices, we're transitioning to breaking this down, but at least keeping the same contract. We're moving this interface into something that can be also publicly available, and we call it API. So services will start communicating through API. And many of us remember this famous email from the Jeff Bezos when he said, like, services need to communicate through APIs. They cannot call each other through through database. Like one system will place something in database, another system will read it from database. So those services need to start communicating through network call. And what we're going into, we actually moving computation into like CPU-based like model into network-based model, where our computation is happening in the network. So we have an API calls. We replace the API calls between the services. We replace the old style of calling the services from in the same like a memory space, in the same process space. Now with this with introduction of network, we have a, let me see if we still alive. I just want to make sure that everyone is here. Okay, so looks like the something with the network. I'm just looking at see. I hope everything is better right now, so at least you can see, hear me, and see the slides. Cody, give me a thumbs up from the other side, and if it's better. Okay, we're good now. Okay, so with the with this introduction of the network connectivity, we need to solve some of the problems that were given us for free. When we're calling one service within the same process, we don't need to think about security. We don't need to make sure that, like, we don't need to think about who will be calling our code, and if there's some malicious hacker was trying to access to our code, its code is local. Now we need to figure out how we can make this call secure, and we need to make sure about identity of the caller. We need to implement a different version, the way how we can do routing, and maybe when we're running the multiple different systems, we need to figure out how we're going to be dealing with the situation, like when we can run the multiple versions of the same service in parallel, and do some of the testing, maybe A/B testing, some of the experimenting, and all this kind of stuff. So there's many things needs to be solved. Things needs to be figured out in the network. So, and it is not no. There's no news. You can say that, Victor, like, what's new here? Like we always done this when we were building our systems in the world of the monolithic application. So if we need to make sure that our system will not failing about database, we're going to be relying on something like connection pool that, first of all, will allows us to have a kind of like a back pressure type of mechanism. So we don't need to send each individual request to database. So we will not have a the overwhelmed database with requests. So the all this connection to the database will be pipelined. If there would be flaky network, we also might rely on, again, the same connection pool that will be performing some of the retries or error handling. Our code needs to make sure that we're handling errors properly. In our code, we're also putting all things around monitoring and all things around all things around like dealing with logging, tracing, understand that this component will be calling this database, and so far and so on. So before I jump right in, I forgot to ask how many of you actually doing like microservices these days. Is it something that you're considering? Is it something that you is this something that you're planning to do, or you're already building this? It's already not a new thing. It's not a greenfield for you. So you're doing this stuff already. So give me some idea. I see a lot of responses around of the greenfield projects are usually microservices, and we see still a lot of responses where people are considering refactoring their monolithic application into microservices. That's very good. That's very good to know. I'm wondering if the people who responded that they're not using microservices currently, can they like put this in the chat real quick, like what's their current deployment strategy and what they do for deployment. Okay. Meanwhile, I try to lower quality of the video if I still will be able to get through this. Right. So now getting back to our monolithic applications, already enough around how to build a system like resilient and how to make sure that is not going. Okay, so looks like the we don't have any luck with good video, so we kill this again. Hopefully, the screen sharing will continue to prevail. That's because it's most important. All right, so with this thing that we build in our application, we're always building this code, and there are many frameworks that already implementing this stuff. So that's why I brought up the concept of connection pool or like thread pool, all these things that may be available for you as a developer. So not necessarily you need to build this yourself. However, you still kind of replicating these pieces over and over again inside your application by implementing frameworks. But it's really good and easy when you are building systems where you rely on only one language and you can standardize framework. But these days we're trying to attract different talent in our systems, to build our systems in our companies. So that's why we don't want to limit them by only particular set of technologies. We want to give them opportunities to build applications in the language of their choice and like prove the concept that that those applications will be able to run in a web scale. So in this case, those pieces of code that you need to bring into different framework needs to have a feature parity. Those features needs to be available on all languages, on all frameworks. In this case, there would be equilibrium of the features inside this application for those application developers. This potentially might cause the problem and introduce some sort of like a fragmentations if some of the frameworks are more advanced, some of the frameworks less advanced, and sometimes you need to implement something yourself, you need to support some of the things, and instead of focusing on solving the business task, we're trying to build another framework. And this thing grows exponentially. So the problem with this concept grows exponentially. And so let's think about this, what we can do about this. So actually, the things that you see on the screen, let me get back. So thing that you can see on the screen is actually the way how, let's call it, service meshes were designed, like of generation one, how the people were trying to build this concept of the resilient microservice deployment. They actually built multiple the features inside their application. So that's why they were like generation one. They wanted to go into this pattern where the handle business logic is business logic, and framework will handle all these kind of underlying technologies. So with this concept, so since there's a framework, what about we can have some sort of external process that will handle all these things that we need it to handle? Specifically in this case, handle retries, error handling, providing a security, providing encryption of the traffic, all this kind of stuff, routing and tracing and all this kind of things. What if there is a process that exists, some proxy process that will be able to handle all this kind of stuff, and it can provide you with very low latency in terms of like introduction, because we're introducing another hop in the network that potentially might cause some of the might introduce some of these how we call it, latencies, some additional problems. So this proxy needs to be fast because it will be standing in execution path of this system. So And the way how the communication would look like in this case, instead of, and like think about the service, it can be database, it can be Kafka, it can be Redis, it can be your application or other application, API calls, and so far and so on. So this proxy will be sitting next to your application. So in this case, they will communicate locally. And there would be like a very limited amount, very limited overhead from this proxy server. And this proxy server will handle all these things that we discussed. Now, the next thing is that would be for us is to configure this communication. So in this case, those proxy can talk to each other, and for example, this TCP can be upgraded to TLS, or we can introduce some of the probes that will be when we calling one service calls another service. We can able to capture this routes or the traces, and we can have a different route, so we can easily reconfigure how the services will discover each other. So in this case, we will be able to build this mesh of the components. And very much it will work on monolithic systems as well. So there's no problem. There's no like microservice specific thing to solve. If you need to introduce like a very quickly things around traffic management, things around like encryption between the services, it still can be used. The same pattern can be used with the monolithic applications. No problem at all here. So, and importantly, that deployment model to deploy this application should be flexible enough that allows not only systems that run inside the containers, run inside the pods, or Kubernetes, like everyone is using Kubernetes these days. However, like we've seen many people who responded in the in this poll, the people saying like they not doing anything. So I assume there might be not ready to go into containers. Maybe they're running in bare metal, maybe running in VMs. So the same model needs to be flexible enough to support those models as well. So you can run this in a physical machine, in your laptop, or if you want to put your laptop in a data center, you can run this in a pod as a Kubernetes part of Kubernetes deployment, or you can run this on the virtual machines. All right, and the one proxy can run in front of multiple replicas of the same service, and in this case we can have ability to scale this design. Now, so the first problem we kind of solved. We offloaded a responsibilities from our application. So we slowly moving to next generation. So we extracted this common piece. We put this in a super fast and super performant proxy server. In this particular case, if you want to get example of in the real world, it's something called an Envoy. It's an open source project. The proxy server that was developed and donated to open source at Lyft, and it's fast. It's written in C++, and it's very flexible to use. So the next step is that how we can configure this. So since I talk about all these things, how we can grow very quickly about this number of services can grow. So we can first, when we deploy our application, we can provide the static configuration for this proxy server. And in this case, it still works. You can have a file that has a configuration and like all the routes and all these kind of things. However, this also not solving the flexibility of deployment in a web scale, because we might need to have a situation when we need to reconfigure these configurations, and we need to have something that allows us to control this configuration and update this in a real time. We maybe want to change this configuration, and we don't want to go through the whole deployment process just to change one configuration parameter. In this case, there should be something that also help to solve this problem. And in this particular case, in we can introduce the component that in this particular slide called the configuration service, but we will have a different name very, very soon. So this configuration service will be able to configure this proxy servers, providing all information about routing, about the traffic permissions, information about encryptions, making sure that all this thing will be like if we're implementing things like MTLS, certificates will be up to date, and all this kind of stuff. And as you can see here, this configuration service is not standing on this in a critical on the path of the request. So this configuration service is not participating in application connectivity. It exists there only to provide the configuration. So in this, the proxy server will be able to communicate and will be able to perform even if this configuration service will go down. So since this configuration service not only provides the configuration for our proxy service, but also allows to configure some other things, we have a better name for this. We call it a control plane, where our applications will be deployed together with small pieces that we will be calling data planes. So this is something that the actual secret sauce of the service mesh comes from the control plane, and the flexibility what kind of this control plane can provide to you, and what you can do and how you can run all these things, and how you deploy your application, and how the control plane will be flexible to configure different components. So just like that, this is essentially what is service mesh. Service mesh, and specifically Kuma, it is a control plane for Envoy that allows to configure and provides the way how you can configure the communication between your systems. That's a service mesh. Two components: control plane that only stores configuration and manages this configuration and make sure all data planes will have same look at the world, and the data planes that will be deployed with your application, regardless if you're running this in a container deployment, or you're running this in a traditional VMs deployment, or running on the bare metal. So those data planes communicate through the local host with our service, and control plane can communicate not only through the local network, but also through the global network. Some of the things that we are doing at Kuma. So control plane allows to propagate configuration to multiple data planes, and in this case, this control plane can run like collocated with the same applications, or it can be deployed in a very geographically distributed system, like have a multiple data centers, and inside our data centers, we call it like east-west traffic, it will go inside your application, and north-south traffic that allows you to have a multiple zones deployed in a different maybe even different cloud provider. So all this kind of stuff is possible to do with thing like a control plane and the service mesh. So essentially, the way how it looks like, so now I will be focusing on specific technologies. Now you have the idea. So this is the generation 2 of service meshes. And generation 2 of the service meshes consist of two components. Data plane, which is going to be proxy server that will be deployed next to your application. In our particular case, it's going to be Envoy proxy. And control plane that will be responsible for making sure that the user experience and developer experience to configuring the services would be on pair. So this is the moment where I need to turn into my terminal. So it's a good opportunity to start another poll here. I would love to learn if people who here who's today, what kind of if you use a service mesh, what kind of service mesh you use, if you're running this in production. If not, what prevents you from doing this. So what I see here, there's a lot of interest in starting using the service mesh. It's great. So that's why we're here. So, and I hope to answer all possible questions that people might have. Okay. 57%, almost half, interested in starting to use service mesh, and the 40% of our attendees today are not using service mesh. No one is using service mesh in production. Well, that's that's upsetting, but hey, that's why I'm here. That's why I'm gonna spend another 30 minutes to showing you how you can do the thing, right? Okay. I'm going into my console, and let me explain one small demo that you will be seeing today. The beauty of this the service mesh design pattern of this service mesh is potentially take any possible application and implement this with the service mesh. So with this, I just was lazy to build my own demo. So I found very interesting demo from the Google Cloud platform. They call it a online boutique. Before that, I think it was something like a hipster shop or whatnot. So essentially, it is a bread and butter of microservices deployment. There's a system that contains multiple different microservices. Those microservices will represent different components on the screen. So if I go to this one, if you can go this even right now. It is in the shop.conproxy.me, and you can play around and see what is going on there. So we can get some of the sunglasses. We can put the address, shipping address, and can place the order. So underneath every screen of this online shop, it will represent the call to particular microservice. So we're going to be using this, and we will break this down for you. So now to details. This microservice system is already have multiple. Where is it? Okay, so we're going into this microservices demo, and inside here, inside *C, we have a sources for different. Let me do view. I will switch to presentation mode, so you will see UI much bigger. So with this, there's multiple services. There's a front-end service that will represent our screen. There's a service about the currency. For example, if I go here, and we will go with this switching to different currency. We'll go with the Canadian dollar. And now all of a sudden we start seeing prices in a different. See, there's a pound, Great Britain pound, and this is a system that gets the exchange rate and that turn this into something that will change. Next thing is that there's multiple different components, and more importantly, those components are written in the different languages. Those, for example, this is like this is the Java card service written in C#, the checkout service written in Go, and so far and so on. So in this case, there's multiple different technologies, but we want to make sense out of it. So the way how we start this, I deploy those into my namespace. I call it a boutique namespace. Go into boutique namespace. There's all these applications are up and running. And one of the things that I wanted to show you that these are different pods that we're running inside the Kubernetes. If you're not familiar with the Kubernetes approach for deploying this, Kubernetes, the minimum unit of deployment is a pod. Inside a pod, you can have multiple containers, and those containers can communicate. They will share local host and they will share file systems. So for example, let's take a look on this front end. So if I go inside the front end, I actually see here a few things. There's a container that will be representing my server. This is the container that runs my business logic. And there's a small container that runs inside the same pod. They're sharing localhost that called a Kuma sidecar. This sidecar also has a init container. So init container will start before all these containers will be up and running, and it will configure network. So all the traffic will go into sidecar first, and after that, sidecar will do the routing. So every component, every pod that they have here, so have a ad service has a sidecar, and card service has a sidecar, and so far and so on. So how does it work? How this stuff came about? So first of all, my Kubernetes already has a namespace that runs my Kong mesh system. So Kuma is the CNCF open source project, Apache v2 license. It is free and available for everyone. We at Kong, we contribute to this project, but also we built a commercially supported product called Kong Mesh. Many things that we will be using today not going to be relevant to any point. I just have this demo that configured with Kong Mesh. This works with Kuma same way as it does. So all this like UI, for example, that I'm showing to you right now, it's also part of the Kuma. So my control plane is deployed here, and this control plane will be start serving some of the mesh capabilities. The way how it works in this particular case, if I go to this namespace, and I would see there's this namespace boutique annotated with this annotation called sidecar injection enabled, meaning that every pod that will start inside this namespace, Kuma control plane will inject a data plane in each of these pods. So the way how it works in this UI, for example, I can go and see all these data planes that are deployed here. So there's a data plane that is deployed next to ad service, next to card service, and a checkout service, and so far and so on. So all these things are here up and running. So I can get the overview of the mesh, and voila. The way how it works with the how you can access this system, how you can go and like play around here. So these services are externalized and available to outside world through Kubernetes ingress. And here I'm running Kong gateway to serve all the traffic. So very soon I will show you how you can visualize all this component, but I would like to show how we can get here. So first thing is that when you open this UI, and this is UI again comes with this Kuma, you will see this help tip, and you can see what you can do here. So the Kuma tries to be very developer friendly, developer focused, and it recommends to enable certain things. And more importantly, all these things that you see, is observability metrics and service map, logging, tracing, and all this kind of stuff, it's kind of recommended to have by default. So let's enable those. So let's enable those. In the way how I can do this, I will go ahead in my terminal, and inside my terminal, I can do, first of all, I'm not gonna silent. Let's do this. Let's do this. So let's install observability tools first. So Kuma and the Kong Mesh, they come with the Kuma CTL, which is a Kuma control, which is a command line utility that provides certain pieces of functionality here. For example, it has built-in capability to install metrics. So I can go this Kuma control install metrics, and it will create a stack with Prometheus, Grafana, and deploy this in my Kubernetes cluster. When I want to run something like I want to install logging, it also will install components that will be capture all these logs. We'll be using Loki to capture those. And the third component that we're going to be using today for traces, we're going to be using Jaeger. So we have a metrics. We have tracing also here as well. So that's what we're going to have here. Hopefully these components are installed here. So what I will do here, if we'll go to metrics and I switch to services, and I will do Grafana and I'll do a port forwarding. We will do port 3000, and we will connect to this port locally so we can have this. Localhost. And I need to log into my Grafana. Again, and password. I will skip that for now. And I would like to see control plane. So by default, this metric is enabled in the control plane, so I can start monitoring what is going on with control plane. So CP, it's a control plane, so we see that we know which node is running this control plane, and we know this from our some Kubernetes data. So let's see what kind of data we will be able to get here as well. So let's see if we will be able to see some data planes information. So is this particular case, we don't see anything. Why? Because we didn't enable this configuration on a data plane. So data planes are not collecting any data. So the way how we can do this, and like all these things that I will be showing to you right now, your Kuma UI is actually can walk you through. So if you go up in here and you want to enable tracing, it will point you to a particular documentation page. But I already have this configured, so it will take me a second to enable this. In this particular configuration, so there's a couple interesting things. So one thing is that Kuma installs a custom resource definitions, and one of the custom resource definitions called mesh. If I will just do here, and let's say kube control. So it's an alias to kube control. So if I do k get meshes, and kube control understand this because it's a custom resource, and we can like configure this mesh through kube control. So you don't need to do anything. However, there's this mesh object has multiple things. So first thing is that, let's see. Let's remove MTLS for now. I will enable MTLS in a second. So I will enable logging, and I will use Loki as a default backend. I will be using Prometheus as my metrics collector, and I will be using Jaeger as my collector for my traces. Next thing is that I need to enable traces for traffic. So every time when the services communicate to each other, this traffic, this information will be sent to Jaeger. Every time when the services communicate to each other, I also capturing logs. So those things will be captured in Loki. So let's take a look how it works. So I'm going ahead and just apply this into Kubernetes. What will happen now in my here, I will see all these traffic policies will be enabled. For example, traffic traces. We have this trace all the traffic. This traffic also, this can be policy that configured against different different services. So if you want to capture the traffic between different services, we will be able to do that. So let's check if I have a correct data sources configured for the Jaeger. It's not going to be Kuma tracing, it's going to be Kong mesh tracing. I will save and test it. Connection successful. Okay, perfect. I'm going into data sources, make sure that here is okay, save. Okay, it works. Loki also needs to, because it has a Kong system mesh logging, so we can configure this communication. Let's see if it does. Yep, it connects. And Prometheus also Kong mesh matrix. Okay, save and test. Okay, good. So now if I go to my dashboard about a data planes, I start getting this information from my data planes. And the reason why I have this information is that I can click around here and the data goes from one service to another. I can do the thing. So going here, switching this stuff. And all these things are here. Add to cart, place the order. So all the things are working here. And this is the traffic between control plane and data plane. I can switch between different data planes here. So I can know that, okay, so we go into the front end and I see like all this observability, how much memory it's allocated, what's the uptime and the responses. So in this case, we have a incoming request when we go in from the gateway, from the proxy, to outgoing to the other services where we're interested in dealing with. In my opinion, one of the things that help you to understand what's going on in the system, and the service mesh allows you to do this effortlessly, it's called a service map. So the service map shows me a topology of the system, how the services are communicating. So let me zoom in. You will see multiple interesting things here. So one of the things is that our front end, this is our boutique front end service, actually communicates with multiple components: currency service, card service, and also a ad service showing some of the ads. Also, information from those services sent to Prometheus. We have a Grafana that also running in a namespace where injection injection also enabled, so we can also see all these services communicating. So front end communicating with this. Now, next thing is that we enable all these things, so we can check with our checklist in the service mesh. So we go in here, we're going into overview. It says where's our meshes. Check our mesh, and now we see. Let me refresh it. We'll be able to gives us updated information about the mesh. I'm going into this, check my mesh, and see observability is enabled, so all good. Logging is enabled, tracing is enabled. So zero trust security. So zero trust security is a whole new topic that I can talk about this some other time, but here I just want to see like one of the components that is kind of like a must on the this type of communication. So we will enable a TLS communication between our services. And there's like a TLS report in this UI, so you can see what services, what certificate they use, when it's expiring, when it was created, and all this kind of stuff. You can see this from the UI, or this information also available through API as well. So let's enable MTLS. So in order to do that, in my mesh configuration, in my policy, I need to put another thing. So for example, if you look in here, we do have traffic trace, traffic log, and in my spec, I want to see MTLS. So MTLS, the Kuma comes with built-in certificate authority, but Kong Mesh also support to use some external systems like HashiCorp Vault as an external certified authority, or you can bring your own CA. So here I'm enabling this default built-in certification authority. That will be more than enough for in many use cases. So I will go ahead and click apply. And now, if I will switch to my click refresh here, and all of a sudden, with just one thing, we just start seeing that every service received their own certificate, so they can start communicating to each other. All these things will be protected by TLS. So let's go ahead and see if our application is still working. Oops, Now we see this unpleasant thing. Why this happened? All of a sudden, our proxy server, our gateway, could not communicate with the services because we enable MTLS, and no one authorized can get this. Why this happened? The reason why this happened is that this particular gateway were not part of the mesh. So if I go here into data plane proxies, this it has two sections. One says standard, all our applications services are here, and there's a gateway. So difference between gateway and the standalone. So we don't need to monitor incoming traffic for gateway, but also this gateway needs to be part of our mesh. So what we can do here, and the cool thing about this, the Kuma UI and Kong UI can actually walk you through, and you can know what you can do here. So you can go which mesh you want to configure. I want to see default. You want to see, I want to have a for namespace Kong. Click next, and what it will do, it's actually generated me a update for my namespace. So in this particular case, I know that my Kong gateway running on different namespace. So it also provides the way how to the Kong can also join this mesh. So in this case, I will just copy this command in the command line, go in here. So what it will do, it will modify my namespace, enabling a sidecar injection, and it will enable, it will join this Kong into my mesh. So let's see how it will work. So to look at how this will work, let's take a look inside Kong namespace. We go in here, we see there's a one terminating, one new will be starting. So we see we start getting sidecar for this. And what we can see here for this proxy, it's up and running, a few seconds, all three are running. So if I'll see, this is the container up and running. So what it will do, let me see. Now it's back. So it is back. Communication between my gateway is working. And now, what if I will go here and I click refresh? My gateway now also is a part of service mesh, and it's a part of the service map. So we see how the traffic goes all the way from our request that goes through the gateway to our front end service to our other services. This is pretty nice, and this is pretty cool to see how the traffic is distributed across your application. So also, like if we go to different, say, service-to-service communication, we will be able to see, for example, where's the Kong? Where's the Kong? Where is the Kong? Kong and front end. We will be able to see how these services are communicating. So let me go ahead, click around, and allow me to do this stuff. Add to cart, so it's still working, all this kind of stuff, place order. Like I said, you can play around with this application even right now. You can go there and let's see if we can see some more traffic. And this is the communication between two services. We will be able to see this with this built-in dashboard, which is pretty nice. This is the tools that you're getting. So the way how it works with the let's bring back to our if I go in here, and now it is running, Kong is running as a gateway proxy. So the way how it's distinguished, that it's running as a gateway data plane. There should be annotation that will tell exactly why it is happening. I don't see it. I forgot. So this is the service name for Kuma. There should be some annotation that says YAML. Yep, let's take a look on this one. We are looking at let me show you how we can learn this from here. So we can go, let's do the service, and let's see Kong proxy. There should be something like annotation for the service or for the pod. I don't remember. We don't need to save any changes. We go into pods, and let's see if we have annotation. See, the Kuma already injected all things on all annotation that we need to do this, and this is the annotation that we need to. No, not different one, not this one. Sidecar inject. Yes. So there's annotation say Kuma IO gateway enabled. So in this case, Kong will be used as a gateway. So we don't need to monitor inbound traffic. Inbound traffic will be handled by. So when you're hitting this application, it's not going through the data plane. When the outbound traffic, when we need to communicate with other components inside Kubernetes cluster, this is where we're going to be using this. Okay, we don't need to save it. Okay, so now let's take a look where we started and where we are right now. So first of all, we started with this. Let's see, check our mesh. Everything should be cool, and the things around the TLS report. Communication between the services is handled certificate authority. We know that when the certificate was generated, when it will expire, because we're specifying this in our policy, this certificate would be updated automatically and distributed automatically by a control plane. Next thing is that all the services are communicating the internal. We don't have a multiple different meshes. We can build kind of like a mesh between different components. We do have standard data planes that we built in our application. So my application, I didn't build those applications. I just took the stuff that the Google folks did this and enabled this. So you can take this stuff and enable in your application. Only things that you need to make sure is application is containerized. You can run this in a container if you're running this in Kubernetes. Or if you're running this in universal mode, there's also a lot of documentation that's telling you how you can configure this. There's a bunch of things that we didn't talk about today. We only configured like a traffic traces, so like all communications will be handled by all this communication. The traces will be collected between all these different components, traffic routes that also allows to communication between all the services. And right now, all the traffic is permitted, but we can enable this and say like one of the service will not be able to communicate to each other. We can be more explicit. For example, since we know this from where is it? Going into Kuma Mesh, given the fact we know how the services are communicating to each other, we can actually create a more explicit communication. We can say the communication only from front end allowed to currency, card service, and advertising ad service. We can be more explicit about permissions here. I didn't show you logs, so let's take a look how we can. Let's see how we can take a look on the logs. So let's see log browser. We're interested in application, say front end, and run query. Show logs. And now we're capturing all the logs that come in from the front end. Also, we will be able to do augment this communication by looking for the traces. For example, if we're going from front end to shipping service, and we can find all the traces, meaning that the particular request will be captured as a trace. We can get this one, and we can see the logs, how they communicate on the both side of things. On the front end, this is logged on the front end service, where we need to call to log on. Is it going back? Oops. Search once again. Too fast. And we're going into what? Shipping service? What was a shipping service? And we will run this query. We're getting trace, and we can, from the shipping service, we will see when it was called. There's no logs found for this trace. Some older logs, no found. Let's see if we have any logs from other. Also, no logs found here. But anyway, so that's pretty much it. What I wanted to show you today. So conceptually, we talk about a. Let me stop screen sharing. Let me see if I will be able to bring my face once again. Hopefully, it's not that bad as it used to be. Learn how you can use the service mesh in your applications. Hopefully, you learn. This demo will be shared in demo scene repository that one of my colleagues. I'm always available to answer all these questions. You can find me on Twitter. But we have questions, Corey, that we can answer right now.
So the only question we received was, how does Kuma operate within the Kubernetes context?
How the Kuma operates within the Kubernetes context. So Kuma itself registered as a listener for multiple Kubernetes objects, specifically about the namespaces that annotated with this particular annotation. So Kuma listens this and does the things based on this logic. So if we enable sidecar injection, we will put the sidecar injection with the configured communication between data plane. So when we deploy this application with the sidecar, this communication between data plane is already will be established. If you look into some other ways, if you want to clarify this, the question, Musa, please, feel free. But essentially, think about this as a Kuma as a controller that sits inside, like Kubernetes controller, that sits inside your Kubernetes cluster and listens all events that happen in particular objects, pods, namespaces, services, and so far and so on.
Excellent. Well, that seems to be all the questions we received. So I really appreciate you coming on to speak with us today, Viktor. Do you have any closing remarks before we officially close out?
So we are wrapping up another release of Kuma very soon. So follow Kuma Mesh in Twitter, and we soon will announce some of the cool features that will be available in Kuma Mesh. I see there's a question about Kuma works with Envoy, Istio, and Linkerd. Okay, so this is a very interesting question. So Kuma, it is a control data plane that only represents as Envoy. So we have components that communicate with Envoy. We know how to communicate with Envoy. Istio, it's another type of control plane that also uses Envoy as a data plane. So in this case, Istio and Kuma, it's more like a comparison about the features that they provide and the way how you can configure one or another, because underlying traffic is handled by the same component. They both using Envoy. Linkerd, on the contrast, they use their own implementation of data plane, and they are not. It's the same pattern, but it is a different implementation. So think about this. It's just like one of the patterns that you can. In the past, people building the service meshes, but simply putting some of the libraries inside their apps, and they will communicate with some of the control plane. So that's the answer for David's question. Yeah, and closing remark. Yeah, I'm going online every Wednesday, like every 2 Wednesday, on the Kong YouTube channel. It's called Kong Builders, where I have a live stream, have a chat with the audience, and we're building some cool stuff. It's unscripted. There are lots of errors, mistakes, screw ups. But it's fun. We kind of like learning something together and solving the different problems together. So if you have some of the spare time that you want to spend with me, I will be available every Wednesday, almost every Wednesday. You can enable notification and get notified when this will be available around 12 in Eastern time. So, and thank you, and DevOps.com for opportunity to speak to your audience. It was a great pleasure.
Well, we really appreciate you having on with us. I'd like to quickly remind our audience that the session was recorded. You'll receive an email with a link to access the on-demand shortly after we conclude. And you can also find it living on the devops.com website. Just visit devops.com/webinars. Quickly, I have 4 $25 Amazon gift cards to give out. Our first winner is Musa Y. Our second winner is Paul A. Our third winner is Cheryl A. And our fourth and final winner is Omar S. So congratulations. Keep an eye on your inbox to claim that gift card. If you don't receive an email, just check your spam folder. Victor, again, thank you so much for being here with us today, for putting together this demo and answering all the questions we received. I'd like to thank Kong for sponsoring today's webinar. And of course, my final thanks goes to you, our audience. We really appreciate you being here with us. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning webinar.